Okay, hello everyone. In this video, I would like to show you how to basically use the reactive transport feature in QAquifolium. I'm gonna start from a very simple example, and I'm gonna expand it into a bit, an example that is a bit more complicated. But I'm gonna keep things as simple as possible. So basically, okay, what I'm gonna do is that I'll use this pond component for doing my reaction. You can use any component that has a storage. So what I'm gonna do first is that I will add a pond component. So I'm gonna go to preferences and then add plugin. And on my system, basically you have to look for the resources folder. So mine is here, and then I'm going to look for this pond plugin, which I'm going to use. So I'm going to add this pond plugin, and I will add some components to my toolbox. So I'm going to start from this stormwater pond. Okay, so I have a stormwater pond here, and let's assign some parameters to it. So let me expand this window so you can see all the properties. I'm not going to have a precipitation time series. Let's say, let's first specify the rating curve for the head storage relationship for the pond. So I'm just going to go with 100 for alpha, and then I'm going to keep beta as 2. And what this means is that if you have 1 meter water depth in the pond, we'll get a storage of basically 100 cubic meters. Okay, so then I'm gonna do initial storage. Let's say the initial storage is 100. Okay, so that's our pond. I can go ahead and run the model right now the way it is, but I'm not gonna see anything interesting happening. There's no hydraulic, there's no flow. So let me save this. So I'm gonna save this model for now. I'm gonna call this reactive transport example. Okay, I already had that file. So anyways, so that's our pond. Now what I'm gonna do is that I will just basically I want to add a constituent, and then I want to basically assign a first order reaction and run it, and we'll see what will happen. So the next step, what I'm going to do is that I will just add a constituent. So this is the icon for a constituent, adding a constituent. So I'm clicking on it, and what I will do is that it will add a constituent for me. Let me just rename the constituent. So I'm going to change the name to A. Okay, so that's the name of my constituent. You can put it anything you want. I don't know, it may be dissolved oxygen or organic carbon or ammonia or anything else. So then next thing what I'm going to do is that I want to, now if I basically select my pond, what I'm going to see is that a new property was added to my pond, which is called A concentration, and that's going to be the initial concentration. So basically let's say the initial concentration is 10, can be any units, but basically I have to be sure that when I define the reactions, the reaction rates or the reaction parameters in general should be consistent with the unit that I use for concentration. So that's what I'm going to have. Now if I run it, I'm going to have this conservative constituent or solute in the pond, and nothing is going to change. So I can actually go ahead and run the model. It's pretty quick because it's a very simple thing. And now I can look at some results. So for example, I can look at the concentration of A, which is 10, and it stays at 10. I can look at the mass, which is going to be 1,000, so 100 times 10. And that's it. So now next step, what I'm going to do is that I will add some reactions. So basically what I'm going to do is I want to add a first order decay reaction. So so the first thing I'm going to do is that I will add this reaction parameter. I mean, it's a good practice to add a reaction parameter so that we can change it more easily, but it's not necessary. So what I'm this icon here, adds a reaction parameter for us. So I just clicked on it and I got this reaction parameter. And then I'm going to call this reaction parameter, let's say, I don't know, decay rate. Okay, or let's say KD. Okay, so I'm going to call this K sub D. And then the value, I don't know, let's say the value is 1 per day. Okay, so now I have the reaction parameter. And so now I can define my reaction. So basically this icon right here is going to add a reaction for me. So I'm going to add this reaction, and I'm going to have this one. I'm going to call the reaction decay. Okay. So now I have a reaction called decay. And so this has basically essentially two properties that I need to assign. One is a stoichiometric constant for A. Okay, can have a stoichiometric constant for all the constituents in my model, but in this case I only have A. So basically now what I'm trying to say is basically the rate of reaction is defined based on the consumption of A. So if that's the case, then my stoichiometric constant for A has to be -1. And this is the way QAquifolium present -1. Kind of a weird way, but anyways. And then we have the rate expression. So that's the rate of reaction, which is going to be an expression, right? So basically what I'm going to do is that it's going to be KD times A. And that says it's a first order reaction. So what we have is KD times A. And now if I run the model, I should see some decay. So let's see, the concentration is exponentially decreasing, same with mass. Okay, now you can define you can have as many reaction parameters as you want to have. You can have as define your reaction as complex as you want, and basically you can have multi-component reactions, monode kinetics, or anything else. So now what I'm going to do is that I just want to make my problem a little more interesting. So I want to combine this with some sort of a hydraulic. So what I'm going to do is that I want to make a copy of this pond. Okay, so I'm going to copy it, and then I'm going to paste it right here. So now I have two ponds. The properties are exactly the same, but then I'm not going to have, basically what I'm going to do is that I will just make the amount of water, I reduce the amount of water in pond number 2 to, let's say, 30. So now I have less water in pond 2, and everything is the same between pond 1 and 2. The bottom elevation is the same. So if I connect these two ponds, what I expect is that the water is going to flow from pond 1 to pond 2 until we get an equilibrium. So the other thing I'm going to do is that I'm going to assume that initially there was no constituent A in pond 2. So pond 2 is clean. Pond 1 has 10 milligrams per liter, or whatever unit of this constituent A. And then what I'm going to do is that I will connect pond 1 and pond 2 using a wide channel. Okay, a wide channel allows water to go in either direction, and it uses Manning's equation to calculate the flow. So what I'm going to do is that I'll just add this wide channel, and I connect the two ponds. So I have some properties for the wide channel. I'm going to make it actually a very kind of narrow and rough channel to have a slow flow. Otherwise, the flow is going to happen very quickly. So what I'm going to do is, let's say, a kind of a high Manning roughness coefficient. I think it's maybe 0.04. And then let's say channel length is, I'm going to make it 20 meters. And then channel width, let's say 0.2. Okay, so it's a pretty small channel. And that's all I have. Let me save the program, and then I'm going to run it. Okay, so that's what I've got. So basically, now let's see what happens to the concentration here. Shouldn't be affected at all because we have water leaving my pond number 1. But if I look at the concentration in pond 2, what I'm going to see is that a spike at the beginning because of this flow, and then it keeps undergoing decay. I can look at the flow here. So let's look at the flow rate. So as you can see, flow happens rather quickly. So water goes from pond 1 to pond 2, and then we'll reach an equilibrium rather quickly. We can also look at the mass transfer. So this is the amount of mass moving from one pond to another one. So again, you see there's basically concentration times the flow, and that's pretty much it. You can make your system more complicated. Maybe if you have two constituents A, B reacting with each other, you can just simply use the same approach, same things that I did to create your network and assign the reaction rate and do the simulation. Thank you for watching. Look for my further videos. Thank you.